All right, so we have learned about the special triangles, and just as kind of a recap here, I know we sort of did a little recap as we finished the first lesson earlier today. But basically what we've talked about so far is we have these special triangles. One of them comes from half of an isosceles triangle. The other one, or sorry, not half an isosceles, an isosceles triangle. The other one comes from half an equilateral triangle. So we know we have the 45, 45, 90 triangle, where we try to shrink this down into the smallest version of this triangle before we go into decimals that are less than 1. So we try to make the smallest sides equal to 1. And then as we solved for the hypotenuse, we got √2 in our previous lesson. And then we also did half of an equilateral, which made a 30, 60, 90 triangle, where again, we made the smallest side of the triangle equal to 1 unit in length. And if this is an equilateral, we said, if this is 1 unit, this is also must be 1 unit if we cut it in half. And if this side is equal to this side, then this must be 2 units in length. And the final side, if we used Pythagorean theorem to solve, we would get √3. Okay, so we are going to make sure that we know these triangles. We will treasure the triangles. We will love the triangles. We will look at the triangles every morning. We will be the triangle. Okay. You need to know these triangles. That's what I'm trying to say. Okay. From these triangles, then we worked, and you guys did some of this in your worksheets as well. We worked to then set up trig ratios of all of these different sides. So what is sine of 30? What is sine 45? What is tan of 60? All of those kinds of things. Okay. So that's kind of what we have broken down so far. Now, there are trig ratios that we can do outside of the range of 0 to 90 degrees. Okay, if I tried right now to plug into my calculator the sine of something that was greater than 90, it would actually give me out an answer. So there are trig ratios that exist outside of right angle triangles. So how does this work? So I'm going to show you guys a couple setup things that we need in order to kind of understand how we do trig of angles greater than 90. So the first thing that we need to know is this is kind of like our quadrant grid here. You'll see that each of these are separated by 90 degrees because of course these are 90-degree angles. You don't have to draw this, but I'm just kind of showing you. Of course, all of these are 90 degrees. So we go from 0 to 90 and then we add another 90, get to 180. We know a straight line is 180 degrees, right? And then we add another 90, we get to 270, and a full rotation, we get to 360. Why does 360 make sense for a full rotation around? What do we know about 360? Relates back to a circle. Okay, a full circle is 360 degrees, right? We all know that, right? Okay. So that's why if we go all the way around this quadrant grid, it ends at 360. Okay, so that's the first part. Second part is a couple things of a couple bits of terminology. Okay, so the initial arm, this is what we measure all angles from. And basically it's glued to 0 degrees. Okay, so if I were to draw this on here, it would essentially just be like a line. This is going to be the arm that we measure from, and it's glued to this 0 degree location. Okay, this is where we're going to measure all angles from. And typically we would measure counterclockwise as we go around. So we're measuring in this direction. We can do clockwise, and we'll talk about that. But for now, we're going to focus on going counterclockwise to measure our angles. Terminal arm. The terminal arm is how we measure is the arm that kind of rotates to measure the angle. So this will rotate counterclockwise, as I said. Okay, and it measures from the initial arm out to a certain angle of measurement of theta. I'm just going to put theta in quotations because theta will of course be something like 125 degrees or something like that. Okay, so I'll show you like a sample on our graph here. Let's say I wanted to measure something like 140, I would measure from here. And if you kind of think about like, you guys remember like the little protractors that you would use to like measure angles, like that's what we're talking about, right? So if I measure like to 140, of course, 140 has to fall kind of between 90 and 180, probably a little closer to 180, like slightly closer. So I would measure it something like this, right? So that would be my terminal, whoops. That would be my terminal arm that measures out to some measurement of theta. Okay, so this would be like theta degrees. We can label them just for our purposes. So this will be the terminal arm. And this will be the initial, but you don't have to label them from here on out. Okay, so we have the initial arm, we have the terminal arm. We're going to be doing units of measurement for angles that are greater than 90. So kind of going into the other quadrants other than that first quadrant. Okay, so we have been focusing a lot in grade 10 on triangles, and that is kind of what we understood trig to be. It was like I use sine, cos, and tan inside a right angle triangle, or I use sine law and cosine law in non-right triangles, and they help me find units of measurements of angles and sides in the triangles. That is true. But trig is really talking more about measurements of an arm as it rotates around a circle. And the idea behind this is if I have some point on the outside of a circle, so let's say I have some point XY on the outside of a circle. If I rotate out to that point from my initial arm, so we talked about this initial arm that lies at 0. If I rotate out there and I want to find information about the rotation, or I want to find information about the radius of this circle, I can actually create a right angled triangle that goes X units over and X units up to get to the point XY. And this is where our right angled triangle comes from. And this is where our some unit of measurement theta comes from, right? To get from here out to here. So we've been focusing a lot on just the triangle part of this, but really we're talking more about like points that are rotating around a circle and how we can find information based on wherever that point is. Okay, we can find the rotation, we can find how far up it is, how far over it is, we can find the radius out to that point. And that's kind of what trig is based in. So we're going to focus a little bit more on this. It also makes the fact that we can have trig of angles over 90 degrees make a little bit more sense, right? Because I can have this point rotating really anywhere around this circle, right? Doesn't necessarily have to be just in here. So if I had a point over here, I could make a right triangle to that point. So this is kind of the thought, and this would obviously be our radius of our circle because it goes from the inside to the outside of the circle. So you'll see me draw this picture again. We'll talk a little bit more about kind of how we can use this in other types of questions, but this is kind of the foundation. All right, a couple more setup things before we get into doing trig of angles greater than 90 degrees. So when I find trig ratios of any positive type angle, so it could be greater than 90 degrees, We're always rotating counterclockwise, as I mentioned. So we measure from the initial arm out counterclockwise. And certain trig ratios are actually going to be negative in certain quadrants, and certain trig ratios will give us out positive ratios in certain quadrants. And that goes back to this kind of idea, because X and Y, if those represent my side lengths, those are negative and positive in different quadrants, right? So like if I go left on the x-axis and I'm in this quadrant, I know X will be a negative number. If I go down and I have a point over here, I know X and Y must be negative because I went left and then I went down. Okay, if I went to a point in this quadrant, I know X would be positive because I'm going right, but then I'm going down. So I know Y would be negative. So the way the ratios get set up for all the different trig ratios, it's going to cause, when I have angles over 90 degrees, it's going to cause certain things to be positive and certain things to be negative because of the X and Y coordinates in those locations. Okay, so the CAST rule is going to help us remember which are positive in which quadrants. And the CAST rule will start. So this is actually quadrants 1, 2, 3, and 4. Those are the names of the quadrants. And we will actually start in quadrant 4 and we will write the word cast going counterclockwise. So cast. And I'm going to explain to you what this means and how this helps us. So I want somebody to choose something in between 0 and 90 for me. Anything, doesn't matter. 80. Okay, we're going to practice with 80. So everybody grab your calculators. You're going to be in degree mode. So just double check that. And we are going to calculate sine 80, then cos 80, then tan 80. And I don't care about the number. I just want to know, is your answer positive for each of them? Is it negative for some of them? What do we get, positives or negatives? So sine 80, cos 80, tan 80. Try them out on your own calculator. And just make note of whether you get positives or negatives. Josh, what do you get? For everything? Okay. So we got positive for the sine of 80, positive for the cos of 80, positive for the tan of 80. And that's because this is the all quadrant where all trig ratios are positive. The reason for this is that in this quadrant, I have positive X's and Y's all in this quadrant, right? So all trig ratios will be positive in that quadrant because all X's and Y's are positive in that quadrant. Okay, so the all quadrant. Okay, I want somebody to find something in between 90 and 180. Colin, can you give me something? 102. We are going to take the sine of 102, the cos of 102, and the tan of 102. Hello. What's up? Cos and tan give you negative. Do you guys agree? So sine was positive, cos was negative, and tan was negative. And that's because the S represents the sine quadrant, and sine is positive in its own quadrant. Cos and tan are negative in the sine quadrant. Okay, so any number between 90 and 180 that you take sine, cos, or tan of will give you a positive value out for sine, but negatives for cos and tan. Okay, let's look at something in between 180 and 270. Sebastian, can you give me a number between those values? 250. Okay, so we're going to take the sine of 250, the cos of 250, and the tan of 250, and I want you to pay attention to which are positives and which are negatives. What'd you get, Chris? Tan was positive, sine was negative, and cos was negative. That's because you might start to see a pattern here. This is the tangent quadrant, and tangent is in its own quadrant here. So tangent is positive and cos and sine are negative. Okay, any guesses for the last one? What's going to happen? I don't think we need to test this. The C obviously stands for the last remaining trig ratio. So Maya, what would we get? Okay, perfect. And that's because this is the cosine quadrant, right? So in the cosine quadrant, cos will be positive and sine and tan will be negative. So you guys can test it with a number if you want. If you choose something between 270 and 360, you'll see you get out negative values for sine and tan, but positive for cosine. Okay, so I will know which trig ratios are positive and negative by just using the cast rule. And I will know, oh, if I'm taking the cos of 230, I know that that will be a negative answer because I know cos is negative between 180 and 270. Okay, so that's the cast rule. The last thing that we need to know in order to do special angles over 90 degrees is this. So any angle over 90 needs a buddy. Okay, the proper name for this is reference angle. Okay, so obtuse angles or angles that are not acute, so in between 0 and 90, you don't need a buddy. Anything that goes over 90 needs a buddy with it. And it is an acute angle that's going to help us determine the exact value when we're given some obtuse angle, okay, or something that's greater than 90 degrees. So the buddy angle will always be the angle in between our terminal arm, so the arm that gets rotated to measure our angle, in between the closest horizontal. So that will either be the 180 line or the 0-360 line. Okay. If my angle is already in the 0 to 90 quadrant, I don't need a buddy. I only need it if my angle is in one of these three quadrants. Okay. So let's use, I think there's an example below of 300. Okay. So firstly, if I want to plot or show the angle in standard position for 300, I'm going to measure from the initial arm. And I'm going to measure all the way around to 300. So 300 should be after 270, and it should be probably a little closer to 270 than it is to 360. We're not going to make this perfect. I mean, if you have a protractor, you can try to make it perfect if you want, but we don't need to make it perfect. I just want you to sort of like pinpoint approximately where a rotation of 300 would be. So I would rotate all the way around here to probably something like right here, and that would be about 300 degrees. Now, because this is an angle over 90, we need a buddy angle, and the buddy angle will be between my terminal arm and the closest horizontal. What is the closest horizontal? Is it 180 or the 0-360 line? See ya? Okay, so it's literally going to be this little remaining slice inside here. How could I figure out what the unit of, or what the angle of rotation is there, or what that angle measurement is? If this is 300, how did you find 60? Right, so if I know this whole rotation is 360, but I want less than that, 60 degrees, then of course that will give me 300, right? So we want to calculate the reference angle or the buddy angle. We want to do 360 minus 300, and that will give us 60. Okay, so that is our reference angle for 300. And I'm going to show you how we'll put this all together in like a single question, but we needed all this base information first. Pardon? Like a protractor? No. I mean, you can if you want, but you don't need one. See ya. It depends. So your reference angle will always be positive. If I had something like 230, let's say, I'm always doing the bigger angle minus the smaller angle. So I would do 230 minus 180 to get this little piece. But if I had something like 140, I would be doing 180 minus 140 to get this piece. So bigger minus smaller. Good question. You'll see us kind of do it in some other questions as we go forward as well. Okay, so far so good. So we have our rotations. We know how to measure angles now. We know about the cast rule and we know about the buddies, right? Okay, so let's start with these. We're going to draw the angles below 250 and 120 in standard position and find their buddy or the reference angle. So if you want, you can draw both of these on the same grid. We're going to label 0, the 0, 360 line, 90, 180, 270. You will have drawn this out so many times by the end of this unit that it will be ingrained in your brain. Okay, 250, where should that go approximately? See ya? Yeah, it should be like about 20 degrees before 270. So I would say somewhere right around here. That would be the unit of measurement all the way around. Okay, is this 250 closer to the 360 line or is it closer to the 180 line? 180. So I want to find, in order to find our reference angle, we need to find the angle that falls between 80 and 250. So how do I calculate that piece right there? See ya? Good. So our reference angle for this one will be equal to 250 minus 180. And that should give us a reference angle of 70. Okay, so that's this rotation inside here. Okay, if you want, you can draw another picture or you can just draw this on the same one. So I want you to plot 120. So make a decision approximately where that is and see if you guys can find the reference angle. I'll give you a second to try that part on your own. So we're trying to find this piece in between here. Because we were closer to 360 and the reference angle always falls between your arm and the horizontal. So that one was closer to 360. This one's closer to 180. No. Okay, so yeah, Ella. It will always fall between the horizontal and wherever your arm is. Okay, so where does 120 go? Where did you guys place that one? Colin, I see that you have it there. Where did you put it?
Closer to the 90.
Yeah, something like this. Okay, so there's our 120. And is this closer to the 180 line or the 360 line? 180. So my reference angle is going to be in between 180 and 120. How do I calculate that little slice there? See ya? Okay, so it's always going to be bigger minus smaller. We'll want the reference angle to be a positive number. And that will give us 60 degrees. So that's this unit of measurement in between here. So find your angles closest horizontal, whether it's the right one or the left one. And then you find the angle that falls in between your arm and that horizontal. Okay? Matt? Yes, you will never be using 0. You will never be using 90. You will never be using 270. So basically, if you're in this quadrant or this quadrant, you're using 180. If you're in this quadrant, you'll be using 360 because you'll be closer to 360 than the 180. Okay, if you're in the first quadrant, you don't need to find a reference angle. So you won't be doing it anyways. Okay, now we're going to put all of this together, the cast rule, our special triangles, and this idea of the reference angle. So let's do this with the sine of 210 to start. So I'm going to just kind of list off a couple steps on top here. So the first one is you're going to draw the angle on your grid. So sometimes we call this like drawing the angle in standard position. So I'm going to make this 0, 90, 270, or 180, 270 grid again. Again, we're going to draw this a lot through this unit. And 210, I should be placing that like just past 180, not quite to 270. So it should be something like probably around here, I would say. And again, that's the measurement, like basically around like this. We don't have to draw that. I'm just placing the arm. Okay, so we drew the angle. Then we're gonna find the reference angle. I don't think you need to, but you'll show it somewhere on here, right? You'll put it on your diagram. Okay, so anything over 90 needs a buddy, right? So we're gonna find its buddy. 180 or 360 line? Which one are we using? 180. So I want to find the unit of measurement in between here and here. What would that be? 30. So we do that by doing 210 minus 180, right? Bigger minus smaller always. So 30 degrees is the reference angle. Okay. If you have a special angle there, you are going to then complete the special triangle in here. So the special triangle, I'm going to actually just create that right angle triangle there. This is the 30, 60, 90 triangle. So I'm going to fill in the opposite of 30 is 1. The hypotenuse of this triangle is 2. And across from 60 is √3. 30 is my reference angle. And the final thing that I'm going to do, so actually we should add that to the steps list, draw the special triangle. We will never create this special triangle with a 90 or 270 line because we are always using the horizontals to find our reference angle. So that's always going to be a leg of our triangle as one of the horizontal lines. So I will never, ever, 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 ever see anybody in this class ever, right, create a triangle like this with the vertical, right? I want to promise from you right now, Colin, that you're never going to do that. So our triangle is always created with the horizontal line as one of the legs of the triangle, okay? Never the vertical, because we always use the horizontal to find the reference angle. So that should always be inside our triangle. Okay, so we drew the special triangle. Then we're going to use the cast rule to decide whether our ratio is positive or negative and set up the ratio. Okay, so here's the process. Sine of 210. If I use the cast rule, I'll put it over here, CAST, we're in the tan quadrant, right? What do I know about taking the sine of something in the tan quadrant? It will be negative. And this will actually be equal to the negative ratio of the reference angle 30. These are actually equivalent trig expressions. So it's negative, again, because it's in the tan quadrant, and I'm going to use the reference angle of 30 to find what this ratio is exactly equal to. So what is the sine of 30 from the special triangle? I want opposite over hypotenuse from this special triangle.
So,
Question?
so sine of 2 times is equal to sine of -30.
Negative sine 30. Yeah. Marcus? It is, yep, because this is opposite and this is hypotenuse. So we will get -1/2. Yes, your calculator knows how to do this. I know your calculator knows how to do it. I want to know that you know why your calculator gives you out the same ratio of sine 30 and 210 and why one of them is positive and one of them is negative, right? So if you type in sine 30 in your calculator, you'll get out 0.5. But if you type out sine of 210, you'll get -0.5. That's because 210 has a reference angle of 30, but it's in a different quadrant, right? So it's negative and positive in some quadrants. depending on what quadrant you're in, right? But 210 has a reference angle of 30, so that's why we can use that special triangle still. Okay, so you're gonna make sure you use these steps as we kind of go through. These are your guides as you go along. I wanna see evidence of your process because I already know that your calculator can do it, and I already know many of your calculators will give you out literally the exact fraction or radical value, okay? I wanna see evidence that you know what's going on. So if you show me on an assignment or a test, I wanna see the supporting work, okay? Let's try a couple more. So tan of 315. You're gonna draw your grid out again. And you're gonna decide where you wanna place 315. Where should we put it? Okay, so quadrant 4, and it should be probably about like halfway in between 270 and 360, I think. That's where 315 is. So that's step number 1. We're gonna place the angle. Then we know any angle over 90 needs a buddy with it, right? So we need to find that reference angle. Are we using 360 or 180? This one's closer to 360. So I'm gonna find the reference angle in between 315 and 360. What's the angle measurement from 315 to 360? Just 45. We can do that by finding 360 minus 315, right? Questions so far? Anything? Okay, we're gonna create the rest of this triangle, which is we're just gonna draw a leg, a right angle up to the horizontal here. Notice again, I'm not using the vertical line. I'm always using that horizontal because that's what we use to find our reference. So here's the right angle. Complete the rest of the triangle. This is 1, 1, and root 2. This corner inside here, that's always where your reference angle will be. And that's always what you're using to label opposite adjacent hypotenuse. Okay, so that's our reference. We finished the triangle. What's the next step? Colin, what do I do next?
I'm not sure if it's like the right order, but
Mhm.
figure out if expansion of the quantity,
Mhm.
which is negative. If you do which is negative.
Perfect. Okay, so we are in the cosine quadrant, but we're taking the tan of something in the cosine quadrant. So I know tan will give me out a negative ratio. So this should be equal to negative tan of the reference angle, which is 45. And then as Colin said, this will end up giving us tan of 45 is 1 because opposite over adjacent is 1 over 1. So we'll get out negative 1. That is, so if you type in your calculator right now, you can check it. If you type in the tan of 315, it actually gives you out the ratio of negative 1. Is it a? So tan represents the ratio of the opposite side over the adjacent side. So it's giving us out that ratio. It's negative because like it's essentially giving us out like information about this coordinate. Remember we talked about the circle? It's essentially giving us out information about that like XY coordinate that's over there. So that's why it's negative. But yes, so when we set up these trig ratios, we're talking about the ratios of the sides of the triangle that's created out of that point, right? On the outside of that circle. Okay, last part for today. Any other questions before I move forward on these? Okay, what if I find a reference angle and it's not 60, 30, or 45? I can't find an exact value of it then. okay, because those angles are not in my triangles. So there's only so many angles that will have reference angles of 30, 45, and 60. If you get a reference angle of like 70 or something like that, you can't find the exact value of the tan of something that has a reference angle of 70. So you would just find it, you can just use your calculator for those ones. Okay, so we're only focusing on things that give us reference angles of the special angles for these types of things. Okay, so far we talked about rotating counterclockwise, but we can actually technically rotate clockwise. That just means we rotate in the negative direction for angles. So if I were to measure, let's say 30 degrees, but clockwise from 0. So if this is my initial arm and I rotate 30 degrees this way, this would actually be negative 30 degrees. Okay. So I can actually switch negative angles into their positive versions by just thinking about, okay, what angle if I rotated this way would have the same location? So if I rotate 30 degrees this way, what's the rotation counterclockwise that would result in a terminal arm in the same location? Josh? 330. So the way that we do this, if I have a negative angle and I want to just switch it into its positive version, I just take the 360 minus that angle. So if we want to switch it into the positive, we'll do 360 minus the angle, or I guess plus the negative angle, and I'll get 330. So the negative rotation of this is negative 30, but the positive rotation all the way around in that same location is 330. So if you're ever given something that's a negative angle, you can always just make it positive by adding a rotation around of 360. So if I'm approached with a question where I have a negative angle inside one of my trig ratios, I'll just make that negative angle into the positive version of itself by adding 360, and then I'll solve as usual. Okay, so let's try that with these last two, or last three, I guess. Okay, well, actually, we're just going to do two. So we will do, I'm going to erase that one. Actually, yeah, I'll erase that one. Okay, so cos of negative 60. The first thing is I want to make negative 60 into a positive angle. So I'm just going to take negative 60 and I'll add on 360 to it. I add on a full rotation around so that I can make it positive. And what do we get? 300. So this should be equivalent to the cos of 300, because we know based on what we talked about here that this is the arm in the exact same place if I just add on a full rotation around of 360. So essentially I'm just taking that arm and I'm just rotating it forward 360 degrees so that it's back in the same location. That's basically what we're doing. So if I want to solve something like this, I'm just going to do the process that we did above. So we're going to draw it out. Okay, like I said, we're going to draw this many times and it will be ingrained in your brain by the end. Okay, we're just going by 90s here. We're going to place 300. So I want you to place 300 approximately where it goes. Okay, it should be closer to 270, probably somewhere like over here. This is 300 degrees. This is also the location of negative 60 degrees, right? So this way is 300 degrees. If I were to rotate clockwise, that's negative 60. So that's why this is equivalent, right? Because it's in the same location. Okay, we find the reference angle from there. It's always going to be between the horizontal and your angle. So what's the unit of measurement of degrees there? in between 300 and 360. How many degrees are there? 60. Okay, so there's our reference. You're going to complete the triangle. So put a line up and make a right angle with the horizontal. And this will be 1, √3, and 2. Okay, final step was we do cast, so C-A-S-T. We are in the cosine quadrant, and I'm taking the cosine of something in the cosine quadrant. So what do I know about my answer? Okay, so cos is positive here. So this should be equal to the positive cos of 60 degrees. Now, this is not always true that this happens. This just so happened to occur because this was an acute angle, and the reference angle is also an acute angle. So that unit of measurement ended up being the negative version of that was equal to the positive version of that. You'll see in the next example that that doesn't always happen. So positive cos of 60, who can tell me the final ratio here? What's that equal to? Using opposite adjacent hypotenuse with this as your reference. Colin?
1/2.
Adjacent over hypotenuse, 1/2. So this will be positive 1/2. Perfect, final answer. You can type into your calculator if you want. Cos of -60 should give you out positive 0.5. You can type into your calculator cos of 300. It will give you out positive 0.5. And you can take cos of 60 and it will give you out positive 0.5. You can check all three of those things. They're all equivalent. Questions on this one? Okay, I want you guys to try the last one yourself. I'm going to give you a couple minutes head start. So start by switching the negative angle to the positive, and then follow the steps from above, and then we will take it up. Right. So if you've done this correctly, you should have gotten -√3. Here's the answer. So first step was to switch -240 into a positive angle by adding 360. So it would have been 120. That falls right about here. Next step, we create that special triangle by finding the reference angle. So in between 180 and 220 was 60 degrees inside there. That was our reference angle. Then I created the triangle from there, and I'd use the cast rule. I decided that because we were in the sine quadrant, tan would be negative. So I said tan of 120 is equal to negative tan of 60. And then we found opposite over adjacent and plugged those in here. So -√3/2, or sorry, √3/1, which simplifies to -√3. Okay, any questions on this one? So in order to do this, you need to make sure you know the special triangles, and you need to know what goes across from what, right? So I always know across from 60 is √3, across from 30 is 1, and the hypotenuse of this triangle is 2. So whatever my reference angle is in there will kind of decide where those other pieces go, right? So you have to know, you have to remember which sides go across from which angles. Okay. Make sure you guys practice this stuff, okay? It might seem like you're kind of like along